Hi students, welcome you all for today's video on trigonometry. In this video, we'll discuss exercise 8.3 in Introduction to Trigonometry. In that, the first question is express the trigonometric ratio sin A, secant A and tan A in terms of cot A. Let's solve the question. We know that 1 plus cot square A is equal to cosecant square A. On rearranging and taking reciprocal for both the side, we get 1 by cosecant square A is equal to 1 by 1 plus cot square A. Right? We know the relation between sin A and cosec A, that sin A is equal to 1 by cosecant A. So using this relation, we can write 1 by cos square A as sin square A. So it will become sin square A is equal to 1 divided by 1 plus cot square A. So taking square root on both the sides to get the value of sin A. So sin A is equal to plus or minus under root 1 divided by 1 plus cot square A. Or we can write it as plus or minus 1 divided by under root 1 plus cot square A. So next we'll go for the tan A. We know tan A is equal to sin A divided by cos A, and cot A is equal to cos A divided by sin A. So by using this, we can establish a relation that tan A is equal to 1 by cot A. Let be the equation 1. So next we'll go for the second A. We have the relation that is secant square A is equal to 1 plus tan square A, and we know the tan value from the equation 1. We'll substitute that here to get the answer. So it will become secant square A is equal to 1 plus 1 by cot square A. Let's simplify by taking a LCM. So it will become cot square A plus 1 divided by cot square A. So that is nothing but secant square A. So we need secant A, so we have to take a square root on both the sides. So it will become square root of 1 plus cot square A divided by cot A. So this is a relation for secant A and cot A. Next, we'll move to the question number 2. Write all the other trigonometric ratios of angle A in terms of secant A. So we'll solve this. We know that cos A is inverse of secant A, that is 1 by secant A. So this is the first trigonometric relation. Next, we know that sin square A plus cos square A is equal to 1. So it will become sin square A is equal to 1 minus cos square A. And we know the relation, the cos A and secant A, will substitute that. So it will become 1 minus 1 by secant square A. So taking LCM, it is secant square A minus 1 by secant square A. So this is for sin square A, which implies sin A is equal to, taking square root, it will become secant square A minus 1 under the root whole divided by secant A. Next, we'll take it for tan theta, that is third trigonometric ratios. For tan A, we have the relation between tan and secant A, that 1 plus tan square A is equal to secant square A, which implies tan square A is equal to secant square A minus 1. So tan A will be under root secant square A minus 1. So this is a relation between tan and secant. So we'll take fourth trigonometric ratio as cot A. So cot A is cos A by sin A. We have the relation for cos A sin A in terms of secant A. We'll substitute that here. So cos A is 1 by secant A and sin A is under root secant square A minus 1 whole divided by secant A. Here secant A and secant A will get cancelled and the answer will get it as 1 by under root secant square A minus 1. So this is a relation for cot and secant. So last trigonometric ratio is cosecant A. So cosecant A, we know that it was of a sin A. So already have the relation for sin, we have to reverse and write it for the cosecant A. So it will become secant A divided by under root secant square A minus 1. So these are the ratios in terms of secant A. So next we'll move on to the next question, that is third question. Choose the correct option and justifies your choice. So in that first one, 9 secant square A minus 9 sin square A. So we'll write the question here again, 9 secant square A minus 9 tan square A. We have the relation for secant square A and tan square A. What is that? That is secant square A is equal to 1 plus tan square A. We'll substitute here. So 9 into 1 plus tan square A minus 9 tan square A, right? So when you open the bracket, we'll get 9 plus 9 tan square A minus 9 tan square A. So plus 9 tan square A and minus 9 tan square A will get cancelled and we'll get the answer as 9. That is option B is correct for this. Next we'll move on to the second sub question, that is 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. So we have the options 0, 1, 2 and minus 1. We'll solve to get which option is right here. We know that tan theta is equal to sin theta divided by cos theta and secant theta is equal to 1 by cos theta. Next, cot theta is equal to cos theta by sin theta. Next, cosecant theta is equal to 1 by sin theta. So these values will substitute here to get the answer. So it will become 1 plus sin theta by cos theta plus 1 by cos theta whole into 1 plus cos theta by sin theta minus 1 by sin theta. So we'll simplify by taking the LCM. So first term, the cos theta is LCM. We'll get it as in the numerator cos theta plus sin theta plus 1 divided by cos theta. And in the second term, we'll get as sin theta as the LCM. So numerator will become sin theta plus cos theta minus 1. So we can combine cos theta and sin theta as one form. So it will reduce to the form of a plus b into a minus b. We know that is equal to a square minus b square. So using this identity, we'll get here as cos theta plus sin theta whole square minus 1 square, that is 1. So whole divided by cos theta into sin theta. So this is in the form of a plus b whole square. So that is equal to a square plus b square plus 2ab. So we have to expand using the identity to get the answer. So it will become cos square theta plus sin square theta plus 2 sin theta cos theta minus 1 whole divided by cos theta into sin theta. We know that cos square theta plus sin square theta as 1. So we'll substitute here. So it will become 1 plus 2 cos theta into sin theta minus 1 divided by cos theta into sin theta. Plus 1 and minus 1 will get cancelled and we'll get 2 cos theta sin theta divided by cos theta into sin theta. So cos theta and sin theta will get cancelled. We'll get the answer as 2. So that is option C is correct here. So next we'll move on to the question number 3rd, that is secant A plus tan A into 1 minus sin A. So option is A is secant A, B is sin A, C is cosecant A and D is cos A. So we know that secant A is equal to 1 by cos A. Similarly, we know tan A is equal to sin A divided by cos A. So we'll substitute here to get the final answer. So it will become 1 by cos A plus sin A by cos A whole into 1 minus sin A. So cos A is common here. So we'll get it as 1 plus sin A divided by cos A whole into 1 minus sin A. So numerator is in the form of A plus B into A minus B. So what is that? That is A square minus B square. So we can write this as 1 square minus sin square A whole divided by cos A. Right? We have the identity, that is sin square A plus cos square A is equal to 1. So from that, so 1 minus sin square A is nothing but cos square A. So cos square A is 1 minus sin square A. We'll substitute here. So it will become cos square A divided by cos A. So one cos will get cancelled and we'll get the answer as cos A. So the option D is equal to cos A is the right answer here. Next, we'll move to the next question, that is 1 plus tan square A divided by 1 plus cot square A. Answers are secant square A minus 1, C cot square A and D tan square A. So we know tan A is the ratio of sin A and cos A. Similarly, cot A is the ratio of cos A and sin A. So the equation reduced to 1 plus sin square A by cos square A divided by 1 plus cos square A divided by sin square A. So taking a LCM, it will become cos square A plus sin square A whole divided by cos square A in the numerator divided by sin square A plus cos square A divided by sin square A in the denominator. We already know that sin square A plus cos square A is 1. So this term and this term is turns to be 1. So it will reduce to 1 by cos square A divided by 1 by sin square A, which can be rewritten as sin square A by cos square A. What is sin by cos? We already know tan. So sin square A by cos square A will become tan square A. So what's the option? The option D is the right here. So next we'll move on to the fourth main question, that prove the following. So that is cosec theta minus cot theta whole square is equal to 1 minus cos theta divided by 1 plus cos theta. So first take LHS, right? That cosec theta minus cot theta whole square. So we have to write this in the simplified form, that cosecant theta is the inverse of sin theta, that is 1 by sin theta, and cot theta also we have to write in this simpler form, so that is cos theta by sin theta. So our equation, it reduces to 1 by sin theta minus cos theta by sin theta, right? Whole square here. So sin theta is common here in the denominator, so we can write it as 1 minus cos theta by sin theta whole square, right? We can separate the numerator and denominator. It will become 1 minus cos theta whole square divided by sin square theta, right? We know the relation between sin and cos. So that is sin square theta plus cos square theta is equal to 1. So what will be sin square theta here? So sin square theta will become 1 minus cos square theta. So we'll substitute that in the denominator, right? So that will reduce to 1 minus cos theta whole square divided by 1 minus cos square theta. So let's observe the denominator, that is in the form of a square minus b square here. So that is identity we will use here, a plus b into a minus b. So numerator will keep as it is, 1 minus cos theta whole square, and denominator will use the identity. So it will become 1 plus cos theta into 1 minus cos theta. So 1 minus cos theta will get cancelled. So remaining answer is 1 minus cos theta divided by 1 plus cos theta. So that is RHS. Hence, prove that LHS is equal to RHS. Next, we'll move on to the second sub question of fourth main. So that is cos A divided by 1 plus sin A plus 1 plus sin A by cos A is equal to 2 secant A. So first we'll consider the LHS. So by taking the LCM of cos A into 1 plus sin A, we'll get the numerator as cos square A plus 1 plus sin A whole square. So 1 plus sin A whole square is in the form of a plus b whole square. So that is a square plus b square plus 2ab. So I have to use this identity here to simplify the answer. So cos square a plus 1 square plus sin square a plus 2 sin a. So denominator remains the same, cos a into 1 plus sin a. So we can combine cos square a and sin square a using the identity sin square a plus cos square a is equal to 1. So we can write it as 1 plus 2 sin a divided by cos a into 1 plus sin a. So what is 1 plus 1? 2, right? So we can rewrite it as 2 plus 2 sin a divided by cos a into 1 plus sin A. So in the numerator we can take 2 as common and it will reduce to 2 into 1 plus sin A in the numerator, and denominator will write as it is cos A into 1 plus sin A. So 1 plus sin A will get cancelled here. So we'll get the answer as 2 by cos A. What is 1 by cos A? We know that 1 by cos A is nothing but secant A, right? So here 2 by cos A is equal to, can we write 2 secant A? That is nothing but our RHS. Hence, the given equation is proved. So next, we'll go for the next question, that is question number 3 in the fourth main. That is tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta is equal to 1 plus secant theta and cosecant theta. So in LHS, we write the simplified version. Tan theta is sin theta by cos theta and cot theta is cos theta by sin theta. So plus cot theta is cos theta by sin theta whole divided by 1 minus sin theta by cos theta. Right? So numerator will keep as it is and we'll take the LCM in the denominator. So with it is sin theta by cos theta whole divided by sin theta minus cos theta divided by sin theta plus, so cos theta by sin theta whole divided by, we'll get cos theta minus sin theta divided by cos theta. So on simplifying, we'll get it as sin square theta divided by cos theta into sin theta minus cos theta. Minus, to make the common term, that sin theta minus cos theta will take minus outside and it will reduce to cos square theta divided by sin theta into sin theta minus cos theta. So you can see here sin theta minus cos theta is common in the both. We'll take it as outside. So it is reduced to 1 divided by sin theta minus cos theta into sin square theta divided by cos theta minus cos square theta divided by sin theta. So this will take LCM to solve further. So it will reduce to 1 by sin theta minus cos theta. Upon taking LCM, it will become sin cube theta minus cos cube theta whole divided by sin theta into cos theta. That is cos theta into sin theta. So numerator, we can observe it is in the form of a cube minus b cube. That is equal to a minus b into a square plus b square plus ab. So it is equal to 1 by sin theta minus cos theta, and applying identity here, so it will become sin theta minus cos theta into sin square theta plus cos square theta plus sin theta into cos theta. So denominator is same, cos theta into sin theta or sin theta into cos theta. So common term sin theta minus cos theta will get cancelled, and we know sin square theta and cos square theta addition is 1. So it reduces to 1 plus sin theta cos theta divided by sin theta into cos theta. So on separating the term, we'll get it as 1 by sin theta into cos theta plus sin theta into cos theta divided by sin theta into cos theta. So 1 by sin theta, we know it as cosecant theta, and 1 by cos theta is secant theta. Thus, on cancelling the common terms, we'll get it as 1. So that is nothing but our RHS, which can be rewritten as 1 plus secant theta into cosecant theta. Hence, proved. Next, we'll move to the fourth sub question in the fourth main. That is 1 plus secant A by secant A is equal to sin square A divided by 1 minus cos A. So we know secant A is 1 by cos A. We'll substitute here. So we'll get 1 plus 1 by cos A divided by 1 by cos A in the denominator. So we'll take the LCM here. It will reduce to cos A plus 1 divided by cos A whole divided by 1 by cos A. So cos A will get cancelled, and we'll get the answer as 1 plus cos A here. So we have to rationalize here by multiplying and dividing by 1 minus cos A to get the RHS. So on rationalizing, we can write here as 1 plus cos A into 1 minus cos A divided by 1 minus cos A. So on multiplying, we will get in the form of A plus B into A minus B. We know that is A square minus B square. So by using that, it will reduce to 1 square minus cos square A divided by 1 minus cos A. So using the identity, which we know that 1 minus cos square A is equal to sin square A. It is from the sin square A plus cos square A is 1. So it reduces to sin square A divided by 1 minus cos A. So that is our RHS. Hence, proved. Next, move to the fifth sub question in the fourth main. That is cos A minus sin A plus 1 divided by cos A plus sin A minus 1 is equal to cosecant A plus cot A. The first step is dividing both numerator and denominator by sin A. So that is cos A by sin A minus sin A by sin A plus 1 by sin A whole divided by cos A by sin A plus sin A by sin A minus 1 by sin A. We are dividing sin A because RHS is cosecant A and cot A here, which will reduce us to cot A minus 1 plus cosecant A divided by cot A plus 1 minus cosecant A, right? So cot A plus cosecant A minus 1 divided by cot A minus cosecant A plus 1. So we know the relation that is in between cot and cosec, that is 1 plus cot square A is equal to cosecant square A. So 1 we can rewrite as cosecant square A minus cot square A. So numerator will reduce us here to cot A plus cosecant A minus, so 1 we can write it as cosecant square A minus cot square A. So denominator will write as it is, so that cot A minus cosecant A plus 1, right? So that is in the form of A square minus B square. What is the identity? A square minus B square is A plus B into A minus B. So we can write it as cot A plus cosecant A minus, using the identity we can write here as cosec A plus cot A into cosec A minus cot A whole divided by cot A minus cosecant A plus 1. So you can observe here the cosec A plus cot A is common. We'll take it as outside. So we'll get it as cot A plus cosecant A by taking outside. So it will reduce us to 1 minus of cosec A minus cot A whole divided by cot A minus cosecant A plus 1. So on opening the bracket, it will reduce to cot A plus cosecant A into 1 minus cosecant A plus cot A. That's nothing but our denominator. So denominator is cot A minus cosecant A plus 1. So common terms will get cancelled here and we'll get the answer as cot A plus cosecant A. So that is our RHS. Hence the given equation is proved. Next we'll move to the question number 6 in the fourth main, that is under root 1 plus sin A divided by 1 minus sin A is equal to secant A plus tan A. So consider LHS. So to solve this we need to rationalize the equation. So rationalizing. So what we have to do for rationalizing? We have to multiply and divide by 1 plus sin A. So it will become 1 plus sin A divided by 1 minus sin A into 1 plus sin A and divided by 1 plus sin A. So numerator it will become under root 1 plus sin A whole square, right? So when you observe denominator, it is in the form of A minus B or A plus B into A minus B. So which is equal to, we know that A square minus B square. So it will become 1 minus sin square A. But we have the relation that sin square A plus cos square A is 1. So 1 minus sin square A will become here cos square A. So we'll substitute that here. So it will become under root 1 plus sin A whole square divided by cos square A, right? Which is equal to square root and square will get cancelled and we'll get the answer as 1 plus sin A divided by cos A. We need to separate the terms to get the answer. So it will become 1 by cos A plus sin A by cos A. So we know what is 1 by cos A, that is secant A, and sin A by cos A is tan A. Right? That's nothing but our RHS. Hence proved. Next we'll move on to the seventh sub question in the fourth main, that sin theta minus 2 sin cube theta divided by 2 cos cube theta minus cos theta equal to tan theta. We'll take the common term outside. So it will become sin theta into 1 minus 2 sin square theta in the numerator, and taking cos theta as common, it will become cos theta into 2 cos square theta minus 1. So next, so sin theta into 1 minus 2 sin square theta will keep as it is, and in denominator cos theta into, we know that relation between sin square and cos square, that is sin square theta plus cos square theta is equal to 1. From this we'll get cos square theta as 1 minus sin square theta and we'll substitute that in the denominator. So it will become 2 into 1 minus sin square theta minus 1. So in the next step, we'll open the bracket. So numerator will be as it is, sin theta into 1 minus 2 sin square theta divided by cos theta into 2 into 1 is 2 and 2 into sin square theta is 2 sin square theta and whole minus 1. So 2 minus 1 is 1. So equation reduces to sin theta into 1 minus 2 sin square theta divided by cos theta into 1 minus 2 sin square theta. So common terms will get cancelled and we'll get the answer as sin theta by cos theta. We know that is tan theta. So that is nothing but our RHS. So hence proved. So next we'll move to the question number 8 in the fourth main, that sin A plus cosec A whole square plus cos A plus secant A whole square should be equal to 7 plus tan square A plus cot square A. So using the relation A plus B whole square is equal to A square plus B square plus 2AB, will expand the given terms. So it will leads to sin square A plus cosec square A plus 2 times the sin A into cosec A plus similarly we'll get cot square A plus secant square A plus 2 times the cos A and secant A. So here next is we have to rearrange the terms. So on rearranging we get sin square A plus cos square A, because we know the identity relating sin square and cos square. Next remaining terms cosec square A plus secant square A plus remaining words 2 sin A. We know cosec A is inverse of a sin A. We'll write it as 1 by sin A plus 2 times the cos A, and secant A in terms of a cos is 1 by cos A. So cos A will get cancelled and sin A will get cancelled. And we know the relation sin square plus cos square is 1 plus cosec square, we know that it is 1 plus cot square A. And we also know secant square is 1 plus tan square A. We'll substitute that here, plus the remaining is 2 plus 2. So here upon addition 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 5, and 5 plus 2 is 7. So 7 plus remaining terms cot square A plus tan square A. So what we got? This is nothing but our RHS, right? So hence proved. So we'll move on to the next question, that is ninth question. So that is cosec A minus sin A into secant A minus cos A should be equal to 1 by tan A plus cot A. So taking LHS, cosec A in terms of a sin is 1 by sin A minus sin A. Similarly, we'll write secant A in terms of a cos A, that is 1 by cos A minus cos A. So taking LCM, it will become 1 minus sin square A divided by sin A into 1 minus cos square A divided by cos A. Right? 1 minus sin square A, we know that it is cos square A. Similarly, 1 minus cos square A is nothing but sin square A. So it will become cos square A into sin square A in the numerator, and denominator sin A into cos A. So one sin will get cancelled and also one cos will get cancelled. So we'll get the answer as sin A into cos A. So let it be the equation 1. So next we'll move to the RHS. So we'll write in the simplified form. So tan A is sin A by cos A plus cot A is cos A by sin A. Right? So next we have to take the LCM in the denominator. So it will become 1 divided by sin square A plus cos square A divided by sin A into cos A. So what is sin square A plus cos square A? 1. So it will reduce us to sin A into cos A. So let it be the equation 2. So from equation 1 and 2, it is proved that LHS is equal to RHS. Hence proved. Next we'll move on to the last question, that is 10th question. 1 plus tan square A divided by 1 plus cot square A is equal to 1 minus tan A divided by 1 minus cot A whole square is equal to tan square A. First we'll consider the first term. So 1 plus tan square we'll write in the simplified form. So it will become sin A by cos A whole square, or we can write sin square A by cos square A. Similarly, in denominator it will become 1 plus cos square A by sin square A. Taking LCM in both numerator and denominator, we'll get it as cos square A plus sin square A divided by cos square A in the numerator, and in denominator we get sin square A plus cos square A divided by sin square A. So using the identity, sin square A plus cos square A is equal to 1, and on rearranging we'll get it as sin square A divided by cos square A. That's nothing but tan square A. So that's nothing but our third term, right? So next we'll consider the second term and applying the identity A minus B whole square. So it will become A square is 1, B square is tan square A minus 2AB. So it is 2 tan A. Similarly, in the denominator, it will become 1 plus cot square A minus 2 cot A. So we have the identity 1 plus tan square A and 1 plus cot square A. That is 1 plus tan square A is nothing but secant square A. So numerator will become secant square A minus 2 tan A. So similarly, applying the identity 1 plus cot square A is equal to cosecant square A, denominator will get cosecant square A minus 2 cot A. So we'll write in the simplified form. So sec is the inverse of cos, right? So it will become 1 by cos square A minus 2 sin A by cos A divided by 1 by sin square A minus 2 into cos A by sin A. Taking the LCM, next step. So what is the LCM? LCM is nothing but cos square A here, right? So when you take the cos square A LCM, it will become 1 minus 2 into cos A into sin A, or sin A into cos A. Similarly, in the denominator, we'll take the LCM as sin square A, and we'll get the answer 1 minus 2 sin A into cos A. So next step is to cancel the common terms, right? So that is, upon cancelling and rearranging, we'll get sin square A by cos square A. So what is that? That's nothing but tan square A. So from these two, we can say that 1 plus tan square A divided by 1 plus cot square A is equal to 1 minus tan A divided by 1 minus cot A whole square is equal to tan square A. So hence proved. Thank you. Please subscribe to my channel Easy Math with Siri.